So let me begin to tell you about the pipeline environment, which is just one of many ways to organize your processing protocols. Way back when I was in graduate school and as a postdoc, we used to use scripts, and people still use scripts. The script, bash scripts, C shell script, whatever script, you know, it doesn't matter what language you use for the script, they're all the same. Something happens linearly. The script takes in inputs, file names, controls, directories, whatever, and it generates outputs. These are provided at invocation time to the script, okay? That was the standard, and this has been the standard for dozens of years. Works great, still works great, it's indispensable, it's just very cumbersome. You know, nobody likes to edit scripts that are hundreds of lines, and then on line 57, one little thing needs to be changed. You know, it's very awkward, cumbersome. Parallelization of scripts takes a bit of effort. You know, people use make scripts, all kinds of scripts, okay? So in 99, believe it or not, long time ago, almost 20 years, we had made a decision to try to optimize this and develop a graphical workflow environment where these scripts become graphs. The nodes in these scripts are the individual processing units that you call, and the inputs of these scripts are all the inputs that go in the scripts. The outputs are everything that comes out of the script. Every pipeline can be implemented and more efficiently as a script, but not vice versa. Not every script is pipeline implementable. So, you know what I'm saying. But I'll show you, so first of all, let me just show you the environment. So, let me just walk you through the basics, and then you guys can choose what resonates with you. So on the website, the pipeline environment is a client-server environment where the client sits on your local machine. That's how you interface it, but all the jobs and executions happen on a remote server. You don't want to hog down your laptop to do computing, and in fact, as far as I'm concerned, no brain mapping should be done on personal computers. It's just too awkward, too intense, you know, bound to human error, failure, you know, lots of problems, you know. Mickey Mouse projects can be done on laptops. Anything seriously needs to be done on a serious platform. And when I say serious, I mean hundreds, thousands of subjects, many dozens of processing steps, you know, imaging, cognitive, clinical, diverse data sets, and all that. So, if you want to use this environment, you can use it as a guest on the USC server without any special, and I'll show you. We'll try to use Eric's computer here to mock up something real quick. Or you can, if you want to be using long-term, big workflows, heavy computing, then you've got three options. Option number one is to become a collaborator and apply for a full-fledged account on the Cranium server at USC, and then you have lots of privileges, storage, you know, whatever that goes with it. Second option is you build your own pipelines backend server on your own hardware and use the distributed pipeline server, to run all the neuroimaging, genomics computing, whatever you want to run on this server. You control access, what tools are installed, you know, it's your business, your shop, you deal with this. And the third option is you run it in the cloud. You rent Amazon, Azure, Google Cloud, whatever space, and you run it there. So these are the options. Obviously, the last two options that I mentioned, there is costs involved, there is IT support involved, there is lots of logistics that need to come into place for this complicated system to work, okay? Okay, so this is, I'm pointing this out if you want to get a full-fledged account on the pipeline server at the University of Southern California. So, the pipeline software you can download the client, if you don't want to deal with a back-end service, updating neuroimaging tools, libraries, grid engine, job submission, tracking, there's lots of things. You just download the pipeline client and you start using it. And you don't have to even download that. You can just start the pipeline web start. I'll show you in a second. We have plugins. The workflow miner is a very interesting feature. Let's see if I open it. Yeah, okay. So the workflow miner allows you to mine the available protocols that the community has developed to help you build a workflow. So for example, I've got nothing here. I can do a search on, okay, well, what should I search for? Suppose I want to search for hippocampal analysis. Just type in something, search, and now it tells, okay, atlas-based hippocampal thickness, direct hippocampal mapping, hippocampal atlas, FSL, first hipposegmentation. So these are some of the things that are known. Okay, so look what's happening here. So let me zoom out a little bit just to give you a little bit of perspective of what's happening. So I type segment or segmentation or something like this. So this kind of tells me various things that can talk to each other, and I can select a branch. This is a dynamic object, by the way. This is not an image, right? So I can select a branch, and it tells me, well, you can download this workflow, brain parser, flirt, FSL flirt, FSL, some process, flirt, I can't read it, something else. So this is a workflow that does something that relates to segmentation. So I can go ahead and download this workflow, or I can select something. So again, these were different types of segmentation related processing networks that communicate to each other, different modules. And I want to experiment a little bit with this. So this is what the workflow miner does. Now I can also open the web app. Let's see if that will work. In a new tab. And here I'm going to go back. So the web app is very preliminary. It's not fully functional yet. So this is to be finalized in the next 6 months or so. But it is working. Maybe about 75 to 80% of the functionality is available in the web app, which does not require Java. The Java web client is the stable version, the currently stable version. Oh my gosh, why is it so slow? Okay, there we go. Something's happening. While this is loading, I'll just go back to here. So that's the workflow miner. You can see the brain viewer you've already seen. So in the, let's see if that's going to work on the Mac. If I click the client, the web start, and I launch from here, keep, okay, so the famous Apple proprietary things prevent you from opening anything that doesn't come from the Apple Store. Well, So in that situation, so let's see, Eric?
You can open it from the settings.
I'm sorry, you can do what?
You can open it from the settings. Maybe you can manipulate the settings.
Do you want to help? Because I'm not exactly sure what's going on here. If not, we can install the client. So the issue here is that, so I want to show you guys both the web app, which is purely HTML based and JavaScript, and the Java client, which is the more fully functional current client. And I want to drag into it the workflow that we kind of generate. Oh, okay. So the JNLP is the Java Web Start program that is about, I don't know, 10 megs or something. It's not too big. But once it finishes downloading, it should be able to start the client. And then, let me see while we wait, is the web app? Okay, so this is loaded. We will try to use the web app in a second. Okay, so what happened now? Is it here? Okay. So while this is finishing the download, basically it installs the client on your machine, and when you start, which I believe is what we're trying to finish here, the client is going to have a graphical user interface, the library is going to be the library of tools, that is, and then on the bottom right you're going to have servers that you can connect to. I'm going to, I obviously have a full-fledged account. I'm going to pretend I don't, so I'm going to use it as a guest. Oh, okay, so the pipeline client, okay, thank you, is starting now. And let me maximize this a little bit. So you see the main canvas where stuff is going to be happening, and a server library which is empty because I have not connected to any server yet. But I can click down on the bottom and connect to the free guest account server. So it's authenticating, done, one connection. So you see how it's updating the collection of known modules and libraries from the server. So we have three types of things, three types of objects here. This cranium guest user, so I'm connected as a guest. In fact, you guys, if you do what I'm doing, go ahead and click on connection and remember this guest ID here, save it somewhere, because you can always go back and see from a different network, from a different computer, the workflows that you have run previously or retrieve results that you have previously generated, but you have to have that unique guest ID. Your guest ID and my guest ID are going to be different things, but save that for the future. Okay, so let me close this. So we have three types of things. We have data sets that you can use. Okay. We have modules, and the modules, they're a very extensive collection. AFNI, AIR, automatic registration, bioinformatics modules are there, brain suite modules, diffusion weighted imaging modules, the European molecular biology open source software is described, FSL and FSL5, free surfer 5, 3, or 6, I'm not sure. ITK tools, there's a lot of LONI tools, including by the way, the LONI statistics tools are exactly the soccer libraries, the soccer Java libraries that are behind some of the web visualization that I showed you earlier with the distribution calculators, various statistical tests, Mink tools, Mind tools, NDAR processing, SVPAs, sub-volume probabilistic atlas segmentation, lots of shape modeling tools, etc. So these are the atomic module types. Now, within each of these, you have a whole suite of individual tools. So if I grab one of these guys and drag it in, it opens it as a module, align linear, and then what I can do is I can try to build a very simple workflow that does a registration right up here, alignment, followed by reslicing, and okay, and what does it require here? Well, model number, let's just go with a 6-parameter rigid body registration. And it's going to ask me for a standard target atlas for registering 2 and a resliced volume that I want to warp or morph. So let's just get some data. Now, the data can come from various places. I'll show you later. But for now, let's just get some of the data that's available here. Okay, well, that's not, wait, maybe that's not the right one. Okay, so I'm going to use as a target of my registration the Alzheimer's disease atlas. I'm going to feed it in, and now look what happens here. It puts in automatically for me a file type converter. This is a smart line that looks at the type of the data that is coming out of this data source, which is analyzed IMG file, and it looks at this one here, which is also analyzed, but it probably detected that some kind of an intensity scale might be needed, or maybe you need to go from 32-bit to 16-bit. Remember I told you about these conversions. So it puts a smart line. If you don't want this smart line, you can always disable it and pipe the raw data without any manipulation downstream. Okay? That's an option. Now, that's the target. This, I'll show you in a second what it looks like. This is the target of this registration. Now I need a data set that I want to register to it. Well, let's try this one. This is another atlas, the ICBM 305 atlas. It comes also as analyzed data. I'm going to fit it in here. Let's leave this smart line in for a second. And then, you guys, what I want to do is I want to put at the end, I want to put a viewer right up here. And what I want to do is I want to show you the target. I want to show you the input. And I want to show you the output. So is that right here what I'm doing? I'm basically writing a script graphically. Very, very simple script. 2 volumes, align them. Spatial normalization. So, now, it seems to be working okay. Okay, so I'm going to first do Apple B, I think, to validate. So I'm trying to validate if this workflow is sound. In other words, is all data available? Are all tools available to the system? Are all connections proper? Is this script error-free? And the answer is green. Green is good, red is bad, pink and orange are in between. So you got validation passed here. So this would run if I run it. Let's go ahead and press run. And you know, So what I'm doing here is a little bit of a Mickey Mouse game, but let me make it a little bit more interesting by pretending that I have 10 of these volumes. I'm going to put in the same thing, but remember, this basically tells the workflow that I have 10 cases, 10 subjects. I can replicate these 10 more times. Okay? So what I'm going to do now is I'm going to reset this. And by the way, at this point, it is a good idea to save that workflow locally.
It's fine. Just save it in the user. Just save it. It's fine. I'll
Wait, how come I can't get to the
Maybe.
to the desktop? Oh, hard drive. Okay.
give it a name.
No, it should be on the desktop.
How do you name?
We're going to give it a name. We need to get to the folder first. No, no. But what I'm saying is that I have a folder on the desktop. Oh, okay, that's good. Thank you. All right, so let's call this my first test, registration test workflow. The .pipe extension indicates that that's a pipe file that's going to be associated with this application. Save this. So where is that? We should have another file here. There it is. All right. So now remember, so how many operations do I have here? I have, let me see, 1, 2, 3 times 10. I've got 30 operations that need to be done. The 30 operations represent the 10 input volumes in here. In step 1, they're going to be converted prior to being fed into the registration module. So 10 conversion steps. 10 steps over here for aligning, spatially deriving the displacement vector field for each of these. Reslicing means that you recut the three-dimensional volumes into the target space. And then finally, we're going to visualize, and we don't count the visualization as processing. It just pops in the viewers. So let's go ahead and run this. It's saved, okay. Now, by the way, while this is running, you can, okay, so it doesn't let me edit it, but you can put metadata about this workflow in the workflow properties, which is not a bad idea, especially if you have the intent of sharing this workflow with somebody. While this is computing, let me just grab the same workflow, Apple A or Control A, Control C, open a new workflow, paste them in, and kind of annotate a little bit so I can say workflow properties. All right, so this workflow is going to be called, well, summer school workflow 1. It's not part of any package. Who described this? Well, we described that. Teamwork. If you want to put in your email address, website, whatever. You put some of that metadata in. If you want an icon, you can put in an icon here for this workflow. You may want to have an image representation of this workflow. Put various tags, registration. ICBM is the data, AD is the atlas. Put some things in. Now, if you have citations, if this workflow represents your work that is peer-reviewed and published, you must put your citations here, because when others use your workflow, they're going to cite you. That's how people cite you. You can openly share your workflow. Just include here the PubMed IDs. Here's examples of how you enter PubMed IDs. And then they're going to appear as clickable links. If somebody clicks on that link, your publication pops in. Okay? So that's metadata about your workflow. And this is interesting. If you want to create provenance files, provenance refers to tracking the history that your data goes through. Okay? Be very careful with this, because this would rapidly increase the size of your storage, because everything that happens into the data gets saved. So be very conservative with this unless you absolutely need it. So now that's a workflow. I haven't saved this one, and my other one that I'm actually working on failed. So that's good. Failures are good. Why? Because if they don't kill you, they make you stronger, right? You learn from the failures. So let's see what's happening here. But I annotated my workflow that's still untitled. I may have to go back and do some of these annotations. Let's see what happened here. So let's look at the failures. So there is 10 jobs, all of them failed. You have 4 tabs that you can explore. The first one is info, which tells you exactly the script alternative that goes with that specific module definition. The script alternative is calling the AIR package, the align linear module, with an input data set and with an atlas and a data that you want to register, and then it outputs an AIR file. Minus M6 says that I want a 6-parameter rigid body registration. Fine, that's the right syntax for invoking this tool. But what happened? Well, let's go to the output stream. The output stream captures from the command line execution everything that the shell would receive once the process starts. The error stream is going to capture everything that the shell generates as output stream. There is 2 types of streams, input and output, and error stream, 3 types of streams. When the things end, you're going to have output files here. Now, these are not generated because the process failed. So let's inspect a little bit what happened here. It says file name. File name, too long of a file name. You've got a problem. So how are we going to fix this? Well, let's see how we can fix that. The way to fix that is to reset that workflow and go back to doing it right. And doing it right indicated that I have to have this smart line here because it fixes my long file name problems. Okay? See? So let's give this thing a try now. I believe that's going to work, but we shall see.
Sorry, you were
Yeah.
saying long file names.
This specific example that I'm showing you uses a tool that's a little bit old, maybe 10 years old. Back a decade ago, nobody used file names that were more than 128 characters long. Well, nowadays we do. So it just barfs on file names being too long. Most of the other routines are not going to complain about it. And there is a fix to that as well. So let's see if that fixes our... Oh, by the way, while this is running, let me just show you. Click here and you're going to see that, oh, you see the tick mark, you know, when jobs finish, okay, and it failed again, so I'm down to 0. You can see that, that's unbelievable. Something is wrong here. The server is not at 0%, but you saw the speedometer was ticking up and down when my jobs were running, okay? So you can track down, you have a quota, okay? I cannot run more than 143 processes. They're going to be queued if I set something larger than that. So let's see, is it the same problem? And why is this? Okay, so I know how to fix that. Or do I? Hold on one second. I think I do. Hold on. Let's see if that fix is gonna help. Let me just do a little bit of renaming here. Oh, I'm just going to call this AD for Alzheimer's disease. Strange. Pasting works, typing doesn't. Well, shorten the names a little bit to avoid that problem with the too long file names, because it concatenates the names of the modules when it constructs these temporary file names. A little bit of a problem. Okay, so let's see if that would be okay. So here is our process monitor. We're at 0. We should be now at 10. Boom. 22. Oh yeah, because I have two things running in parallel, right, you guys? I have these guys and these guys together, so let it finish. As jobs finish, you see how you kind of go down, kind of tells you where you are. Oh my goodness, that's going to give me heartburn. What's the problem now? Alright, bear with me, I have to put another converter here. Apparently the data that I chose may be a bit tricky. So hold on one second. Let me put another little converter here. In between these two. Let me see, that may or may not be enough. Actually, hold on. Because I don't know exactly the metadata about these about these atlases, I may need to experiment a little bit. But this is actually good for you guys because you can see exactly how things happen in practice. Trial, error, revision, redesign, you know, that's exactly how these workflows get generated. Let me try that now. So I just put in an extra converter that transforms the data into 8-bit just to make sure. It was complaining before that the intensities of the image were odd. I don't know why. I don't know what these images look like. So I'm going to put in an extra converter that scales the intensities down to 8-bit. And I'm hoping that's going to fix the problem. If not, we can try some. And you see how these workflows, they tend to balloon a little bit. Just like when you write a script, you start with a very simple script. Get the data, average them, and then all of a sudden, well, trim the average, you know, normalize, whatever. So the scripts kind of tend to implode a little bit. While this is running, let me show you another trick here. As these things become more complex, you guys, you begin to be more creative. So let's try to package two of these together in a group. Control G. So here is my new group. I can give it a special icon if I want to. So here is the special icon for this my group. And now you see I'm simplifying my workflow by having nested functionality. And if I want to expand it, just double click on it and it puts me in a higher level, in a deeper level in my workflow where I can see the exact modules that are defined inside of it. So that's my top level. I just showed you the nested inner level. Let's see what's happening with this workflow. Okay, well this one is successfully moving forward. So we cracked that problem of long file names. We cracked another problem of the intensities being odd. So this is down into, well, I don't know if we cracked the problem. Let's see. Oh my gosh, this didn't work again. 10 jobs failed. What's the reason now? Okay, let me try. Okay, now look, you guys, sometimes you're going to get in these situations and you don't want to be recomputing the stuff that was already computed. So look at this little trick here now. I'm going to select all of them, copy them, open yet another new workflow. Actually, step back. Just select the bottom 3 of these guys. Just select the remaining modules that failed execution. I don't have to redo the previous modules. And then I'm gonna copy them with input. Go over here, paste them in, and only run the stuff that failed. See, I want to leave the stuff that was computed so we don't have to wait the extra minutes. So now I'm going to experiment here a little bit, so bear with me to see if I can fix that annoying problem. And one example is to use a line linear instead of a line linear 8-bit. See if that's going to be any better. Reconnect it to the inputs. Specify that this is again a rigid body registration. Remove the old module that failed. Reconnect these input and output. And run that. I'm running only the failing part of the workflow. If this is successful, I'm going to go back and revise my original workflow so that I have an end-to-end that works. Yeah.
And this pipeline we use to pre-process your images.
Yeah.
Okay.
Yeah, I'll show you examples. My point right now is to show you the working of the environment And then I'm going to show you specific protocols for pre-processing, segmentation, you know, parcellation, and all kinds of other things.
And all you need to do is just to load the MRI.
Yeah. So, okay. So note, you guys, this is now successful. So I've proven to myself that I need to swap that module in the previous workflow, and it's going to run end to end, hopefully. But before we do it, let's just make sure it does run all the way. So it needs to. Oh my gosh, it's going to be painful. It's going to show 10 times the inputs, the outputs, all these things. I can stop it, of course. I can always terminate it. But I wanted to show you a little bit about how does the viewer show you the target of the registration, the original data, and the resliced data. And because we have 10 input data sets, this is going to be repeated 10 times. So I'm going to put a stop to this quickly. But let's just see, okay, this last conversion, 90% done. Okay, so look what happens now. I should be seeing these pop-out dialogues that illustrate the viewer. Okay, while this is doing, let me just copy this, revise my original workflow, reset it. You can edit before you reset. This I'm going to delete. Oh my gosh. Undo. Delete only that. Plug in the right one. Reconnect. And save. Okay. So where are we here? Oh, now the viewer failed. Okay, what's the problem here? So that's what these module definitions look like. So for example, here is where it defines these connections, the executables. Here are the icons that get stored. You know, the icons are really big because they're binary images represented as okay. See, there is descriptions. Here is the module ID name, inputs that are defined in them, how much memory they require, all kinds of metadata about. So this specific module uses Java. They have some information about the type of the data, the format, etc. So this is XML description of how to call a standalone executable on this system. It doesn't really matter what the language that was used to compile to generate this executable. In fact, it could be an interpretable script. It could be a script that you wrap in XML and call it instead. Make sense? Okay, so let me see if I can show you guys how to okay, so this finally opened. I think it was just a network problem. Remember when I kept dragging in and clicking in these things? So let me try this again. I was trying Brain Suite. Not the modules. I need the workflows. Okay. So this is a workflow, for example, that does the following. Notice this is the thing that I showed you. There is a website for this developer. There is a licensing information. Click on any one of these links and you're going to get the information. Citations, the PTMI. If I click on this link, it leads me directly to the corresponding paper. You can cite them, read the paper, any details that you may want to know about the protocol is going to be available there. So here in this specific tool, for instance, you get a whole head MRI. It does the surface extraction, bias field correction, partial volume classification, cortical surface modeling, topological correction of these to patch holes and handles, and then generates the surfaces, smooths them a little bit, and then splits them into the hemispheres, does a peak harmonic mapping, and then it generates a left and right peel surfaces. You can start this workflow or modify this workflow, or on the very top of the workflow, you can enter your own data. See, this is a raw data that you guys specify. And then you can just run it.
It doesn't matter what format.
No, it does matter what format is the data. In this specific case, it needs to be analyzed. If it's not analyzed, it's not a problem. You just plug it in, connect it, and if it knows that conversion type, it would convert it on the fly. If it doesn't, you gotta choose one of our converters here. There is plenty of converters to convert it from the provided type into the necessary type, and it's still gonna work. So it's validating right now, 99% complete. And then it starts running. Now this cortical surface extraction may take a while, maybe, I'm not sure, but I wouldn't be surprised if it takes 20 or 30 minutes at least. But it generates a really beautiful cortical surface representation that you can visualize, obviously, drag it in the brain viewer, or you can compute various things on it. For example, the curvature, fractal dimension, surface area, all kinds of things you can. These are biomarkers. These are derived neuroimaging biomarkers that you can compute on the cortical surface. You can compute the thickness of the gray matter. You know, you can do asymmetry, left versus right hemisphere. You can do lots of things once you have the model, right? So I'm just showing you guys, in the first step it removed the skull and the dura and the tissue that's non-brain gets removed. This is just, it always shows, these are called thumbnails images. It shows the mid-axial plane cut through just to see if the output is something that you expect it to be. Then it does a Bautfield correction to make sure the image is not getting brighter or darker as you go from left to right or up or down or something. It makes them homogeneous in a way. And then it's going to do the partial volume classification into white matter, gray matter, and cerebrospinal fluid. You may want to save these as well, because oftentimes the amount of gray matter, that's an indicator. In Alzheimer's disease, it shrinks. So after this partial volume classification is done, there'll be an IMG volume that you may want to save out. You know, I'm not saving it here because that's not the process. It's not saved by default, let's put it this way. So that's one example. The converters, again, you can do search for the library to find out various converters. Here's another example that I loaded for you. So this specific one does brain volume parcellation. Okay, I have to go on. So it uses again the ICBM Atlas as a target, and in this case just any. So here are, for instance, 10 volumes, 10 different MP range volumes that are plugged in, and a reference atlas. And then you see what's happening here. So you have the volume pre-processing groups of modules that, you know, do some registration and so forth. And then in the next step, that's another group of modules, and that's a third level. You see on the very top the depth that you're going into in that functional call. So you go 3 levels deep. And of course, so is this one. And look at the important thing. The pipeline is very interesting because it allows you to integrate, make tools that are not designed to work together. It makes them interoperable. FSL, ITK, LONI tools worked in the same process here. CCB tools, brain parser, you know, variety of things can be patched together. That's why these protocols get very complicated very soon, but it doesn't really matter to you, because once it's designed and validated, it can be shared and manipulated. If I'm not happy with a specific module, I can always delete it, swap it with something else, and it's a new workflow, right? Okay. So let's see. Our thing is running here. What was that? That was the thing that we just finished. So I'm going to reset that. No. I'm trying to clean my environment here. So this is the workflow that we finished designing, and here are a couple of workflows that are predefined. I'm just running them. Look what happened here. This workflow generated another error, so you may want to inspect this error just like we did before. Unable to write. And by the way, this is my guest ID. It creates a private directory for me. It says maskbrain.img. It doesn't let me overwrite it. So let me reset and see if there is a force overwrite option here. Brain mask file. I'm not sure why this failed. We need to look at it offline. But you guys get the point of how you kind of navigate things. Now, there is a few other things that I want to show you about the pipeline. Let's go back to that? Oh, because I killed the browser. Oh my gosh. I'm sorry, when I killed the browser earlier, I lost the session that we have. But that's not hard to recover. I just wanted to see, just to make sure we are... okay, so that's the environment, that's the client GUI. Module definition. I haven't shown you how to create a module by yourself. I only showed you how to utilize existing modules and connect them to form a workflow. Now let's go quickly and define a module definition. Okay, while this is running in the background, so the easiest way to define a module definition, by the way, is to grab another module definition and just change it. Okay, so let me grab, I don't know, this one. Control C, open a new workflow, paste it in, and now here you right click edit the module. Now, this icon is not going to be appropriate anymore. You're going to remove any other metadata that might be there. Let's go with test module. It's not associated with a package, so I'm going to remove some of that metadata. And now you go to module execution. You have to specify. You have to specify. Let's see. What kind of commands do we have on a Mac? Because I want to run one thing local. Obviously, I can go on the system and type something like bin cat, okay? And then the parameters, I need a file name, input file name, and it doesn't have any output file names. So I'm going to delete these parameters. Delete these. So it's going to be a very simple module. Takes one parameter that takes an input file, and no, let's just do more. Let's just open the content of a file. Simple. Or if you want to do, I mean, let's do more. And then it's going to take in a file as an input, and it's going to be any file. It's going to be any file. And so this is my test module. It takes in an input file, and let's go ahead and, I don't know, take an input file locally or from the browser. Well, unfortunately, maybe I should take a local file. I don't want to mess around with Eric's computer. Oh no, wait a minute, I do have a file here. So cancel that. Have it a local file. Browse. So what do we do? Hard drive. I'm sorry, so where was that? Yeah, why don't we do that? Let me run this. Okay, so hold on one second. Let's make sure this runs locally, because at execution, oh no, I want it to run on the server. That's fine. Okay, so let's try that. So what's happening here, you guys, is I'm doing something slightly silly. I'm trying to grab a local file, send it to the server, and then I'm trying to see the content from the server. It's not happy. Why? Oh, the executable doesn't exist. Okay, let's see. Is it? is it bin more? Can somebody with a Linux shell tell me is more in bin or is it in? I think it's bin.
Yeah, bin more.
All right, so again, what I'm doing here is I'm defining a very silly module that reads in from my local system a file, sends it to the remote server, reads the file and shows me the content of the file. So here is the invocation. Oh, it's not a -i. I'm sorry. I should change the flag. That's why copy pasting does not work directly. What I did is I left in the flag of the parameter, which was not right. So I need to go back and remove that -i flag that's defined for this input. See the -i flag? I need to remove that.
What's that?
And then if I run this should be okay now. And I should just see my R script content. Remember, this could have been an image that goes in and the process could be computing the average of the mean or something like that. All right, queued, complete. Now, so where is the content? Where is the text of this file? Well, right click, output. Here, does everybody see my R script here in the shell? So, my own file, I had to send to the server, read it there, send it back to me, and I see it right here in the output shell. A little silly, I agree. But it kind of shows you the notion of, first of all, multiple server communication, right? Porting data to the server, retrieving the results, albeit silly results, and the execution of more. Nobody cares about that, but the rest of these modules are defined exactly the same way. Look at these guys here that just completed. Let me just show you what they look like. Copy this, go back to our module design here, reset it, paste in the new module, and then open this in editing mode. And now you can see that this module has a whole bunch of parameters, some of which are files, some of which are strings, some of which they have different types, right? They could be directories, they could be numbers, they could be flow control, they could be various types of files, and some of them are inputs and some of them are outputs. Look, some of them, if input is not toggled on, it's an output. Some of them are required, some of them are not required. Optional parameters, that is. So you see how I have a whole bunch of parameters, but the module shows me only one input and one output. Well, because it only shows you the required ones. The non-required ones you get by double-clicking, and now you can do selection here to put in extra flags or extra parameters if you want. You see, to make the module more elaborate. So this is essentially script modification on the fly. Right, you guys? All right. So that's how we define a module. That's the workflow that we... Oh no, I'm sorry. It's the wrong one. Didn't I download one from the minor? Yeah, the download pipe. That's the one. See, you guys, that's the workflow that we downloaded from the workflow minor A. Why Zoom doesn't work here? Anyways, so you see, the workflow that we downloaded is not completely connected, right? Look at this. There is a flow of control that hangs in there. It's not linked to anything. There is a few missing parameters. So these are things that you may want to consider including in a workflow that has to do with, in this case, I think it was segmentation. You know, if you're going to be doing segmentation, some of these modules may be appropriate for you. So, you know, brain parsing, FSL, this module does, I'm not exactly sure what, copies certain part of the header information, etc. FSL flirt does linear registration. Bit converter again changes the intensities a little bit, and then it computes a hard mean if you have to compute mean of a bunch of subjects. Yeah.
Can you step us through like the simplest version of, let's say, raw image to select maybe to matrix?
Okay. This work. Okay. So this workload I'm showing you guys up here. Well, it's going to take a while. Maybe it's going to be finished by tomorrow. Most of the things, they do require a little bit of work. So right here, the scope stripping takes 20 to 30 minutes. The battlefield corrections took 3 minutes. So it adds up. So there is no really. Let me see if any of these might be a little bit faster.
Can you do like just one image and stuff?
Yeah, it doesn't really matter how many images because they go in parallel. That's one of the beauty of the pipeline workflow. It's just that the individual, you see, scope stripping is going to take 30 minutes. Why? Because it's a difficult process. The tissue gets connected, and exactly the decision making of where to code it, brain and non-brain, is complicated. So many of these things do take a little bit of time. But let me see if I can show. Under training, there is a few workflows that work fairly well and fast. Let me see if any of these is going to resonate with you.
Say like just processing MRI.
Right, but what do you mean by processing MRI, right? This may include, lots of things. So here is an example, again, something that I showed you earlier that does alignment followed by scope stripping. That's perhaps too simple. Let's just get rid of this. This one we're going to get rid of. This one we're going to just close. This one we're going to close. Let's keep that one. So that was the one that failed. We can close that. So how about this? This one does, this one does actually, again, scope stripping, intensity homogeneity correction, partial volume classification, which is tissue classification. That's a simple protocol. I believe this one runs in something like less than 5 minutes. We can run that. It generates tissue maps at the end. While this is running, there is a diffusion tensor imaging protocol that you guys can try if anybody is interested in. FSL registration, scope stripping. There is a whole bunch of structural analysis workflows in here. Tissue classification again. So depending upon what your goals are, you typically use the keyword search here, find candidate workflows, modify them if you need to modify them, plug in your own data as input, validate the workflows, and run them. And oftentimes that leads to modifications because something either didn't work right or the results are not good or something. So this is another one that does the partial work. Yeah, that's an interesting one, and I believe it runs fairly fast. It generates volumetric counts of different tissue maps. So we can run this one as well. Right up here, it generates a table of the volumetric counts for different tissue types. That's an end-to-end workflow. Now these can be added at the end, again, to augment your clinical scores as covariates or something, either in a classification setting or in some kind of a other model-based prediction. So there's various things that we can analyze. Again, most of these things will take time to finish, as you can see. All right, actually, this is done. So let me see if we have. Yeah, so I'm not sure if you guys can see. Okay, so why don't we try that? So this one, I can probably download the tissue classification volume. Well, oh my gosh, that's going to take a while. 14 megs. You know, might take a while. I don't have to queue it. But at any rate, the resulting volume here, the input was raw image. The resulting volume is a stepwise function that has, I guess, 2 for the gray matter, 5 for the white matter, and 8 for the cerebrospinal fluid or something like this. Everything else is 0, right? So that's a result. And then once you have that image, you can pipe it through the FSL stats to compute, well, what's the volume of the gray matter, what's the volume of the white matter, what's the volume of the CSF. These are derived neuroimaging biomarkers, right? You can go further than that, and that's what this workflow that we started off with is, essentially parcellating the brain into different regions and doing the same thing ROI based. You know, for each region, separate statistics are being computed. But they do take, as you can see, okay, so this is 90% done in the skull stripping, the remaining 10% of the subjects, which is probably one subject, remains to be finished. Again, you guys can track the progress of all of these. Oh, I think it just, oh no, the first one is still running. The green ones are finished. I can look at the output stream, error stream, and output files. Right? Inspect results and so forth. So let's see. All right, so I showed you a little, okay, I was going to show you a little bit about the documentation, but what other things might come to, you know, specific solutions, specific workflows, we may have to talk offline because that's a research question, right? How do I go from point A to point B? There are bits and pieces and maybe even solutions that fit right out of the box, but most of the time it is the case that you have to manipulate an existing workflow to get what you specifically need for your study. But the important thing is to get the notion that data gets fed in the data sources, and I'll show you maybe next time how you can get data from Box, Dropbox, Amazon, IDA, XNAT, as well as from the local file system. I just showed you how to get data from the local file system with this R file that we sent to the server. It was not for computing, but illustrated the notion of piping files back and forth. And the rest is mostly research oriented. You got to decide exactly what protocol you specifically need. So this notion of documentation, one of the workflows that I'm computing right now is documented right up here, global shape analysis. That's a very elaborate workflow you guys may want to look at. It's got descriptions of the workflow, you know, some snapshots, and it ends with descriptions of the morphometry measures that it calculates for you, and some citations, you know, grants, pubs, etc. So most of the other ones look exactly the same. So typically here you're going to want to do a search on a keyword or a phrase to find out if there is something available as to what you need, and then modify this a little bit. Cortical thickness workflows, elastic surface warping, you know, etc.
So are these workflow available on the
Yeah, they are available in the library, and they are also available here. There, you can download them from the wiki as well. I believe most of them are listed at the end as, right, if you go to the end, this is the actual PI file. I can download it from the documentation page, load it in the workflow, and, you know, test it. Okay, so let's see. The workflow library. The workflow library is another way to navigate the possible solutions. You can use either a directory tree or a tree organization, wheel organization, you know, kind of double click in any one of these, and I think you can zoom in here to see this a little bit more clearly. But double clicking on any one of these, oh my gosh, I overdid it, didn't I? So, all right, so Shape Reporter, if you double click on it, it kind of pops in this, now I need to zoom out. It pops in this, you can view the source, you can download the source, or you can run directly the workflow. So let me just go ahead and download it. This one is just a single, that's strange. This was a single module, not a workflow. Oh, okay, so I need to be over here, I guess, for the workflows. Oh my gosh, they've got some kind of a problem. I gotta let them know. Okay, so this, apparently something is malfunctioning right now for the downloading the workflows from here, but you can kind of see some of the organization. You can also do a keyword search here. It's probably better to do it in the directory view. It's a little bit. Okay, so it shows you things that have to do with registration, both in the modules space, in a data space, or in the workflow space. And now these things should work here, I know. Wait, is this the download? The download is that link. All right, so, okay, so finally something happened. This shows you the 3 tissue type classification output that I mentioned earlier. The workflow ended that, and it pops it in for me. And you can, I believe you can, yeah, scroll. This is a 3-dimensional volume. You're kind of looking at cross sections. A very simple viewer to illustrate that. Indeed, you know, okay, so cerebrospinal fluid, just like I thought, was 8, and then the gray matter and CSF are the other 2 colors, whatever they are. So let's see where we are with these executions. So I believe this was the result of this, wait. All right, this is done. Let's go ahead and look at some of these tables. Output. And you can view them. They're small files, so we can actually download these things fairly quickly. Okay, so here are the total brain volume, and then the three metrics I believe are gray matter, white matter, and cerebrospinal fluid. Let me see if that was. All right, this simply lists them as a column vector, the very same values. And of course, you can copy paste these things or put them in an Excel spreadsheet. If you this is just one volume, okay? If you had a whole bunch of volumes, you're gonna have a whole bunch of these metrics. Download them, etc. Now remember, in this case, this is just one of the things. Let me just see here what is coming out of this end. Oh yeah, these are the free surfer stats. Let's look at some of these. Wait, download complete. So I need to go to my directory. Okay, so all right, so these are the. I just need to open them as from a text with a text viewer. All right, so look, these are the free surfer stats. I don't know how to make this. View, zoom in. All right, so you have rate. So I'm not sure what the zero labels correspond to, but you have the corresponding gray matter, white matter. Okay, wait a minute. I need to think about that. Remember, you have 4 labels. One is background, and the other 3 tissue types. Now, to figure out exactly which one is which, we may have to how do you exit from the full screen? Okay, there we go. So to figure out which one is which, we need to dive in the documentation of some of these tools that actually generate the partial volume classifier. Let's see if we can figure that out quickly. Okay, so 0 is CSF, 1 is gray, 1 and 2 it says are gray matter, 3 is white matter, etc. So you can see some of these labels that are associated with the counts, the volumetric counts that we got. So you got to go to the documentation of the specific tool to make sure you interpret these things correctly. All right, so this finished pretty quick. So at least we have one example of going from a raw MR to some numbers. They're global, they're not regional, but you know, the regional ones, they will be done by tomorrow, these guys, and we're going to be able to see some of the results and talk about them. All right, so let's stop here. Any questions or ideas?
So,
Yeah.
so the guest name that you were given will always be the same guest name.
Well, okay, so the way it works is the unique guest name is assigned. I believe it's assigned per MAC address, which means that on this machine, every time you open the pipeline client, it's going to default to the same guest. But if you switch a machine, or maybe even if you switch a network, you may have to remember the guest ID, because without you entering it, it's going to give you a new guest ID, and you're not going to be able to see your workflows that you started. So what I'm going to do now, before I forget, is I'm going to go back and remember my guest ID, because tomorrow, who knows? So this I need to copy, open a new file somewhere where I can save my guest ID. Okay, so how do I open a new file here?
Just get back to text edit and put in there.
Open like this and do what? And do new file?
Command and
Okay. All right, thank you. So that's my guest ID, so I need to save that file as but how come it's not showing me which folder? Okay. All right, so we save that. So next time we should be able to track the so now, 1 second. Before I close, so we have that, so close that. So I'm going to disconnect from my server, and I'm going to close the client. Okay, wait a minute. Let's make sure I don't lose some work. So this is, let me save this. Okay. Oh no, wait a minute. Wait a minute. I don't want to overwrite this. So this is the auto. ROI extraction. Okay, so I can close that safely. This one, well, we did this one, I don't have to save it. This one, we're done with that. Let's just kill it.
So even if you close it, it's still running at the background.
Oh yeah, right. So okay, so remember how I disconnected from the server, you guys? I'm going to close the application. It's running on the background. I don't have to worry about it. You know, in fact, let me just reconnect and check the status real quick. Wait, no, don't remove that. So why is it not letting me close this? Oh, but okay, tomorrow I'm going to show you some of the web app functionality. Okay, so the R Studio I can close now safely. Don't save. This we need, that we need. Well, I don't know why it's not letting me quit here. I'm trying to quit the application. Do you guys know why it's not quitting for me? Anyways, I wanted to demonstrate restarting the app and then reconnecting, but we can probably do this tomorrow. Huh. Maybe it did work. Okay, but now, so Eric, how do I reopen it? Where was oh, is it this one? Okay. Okay. Also, it needs to re-download it? Oh no, it's already here. Okay, that's good. Alright guys, so here are my 4 sessions. We just restarted the app. So you can pull back all the workflows. They sit on the server. They stay for a couple weeks. If they're not, if you have to, data that you have generated, if you haven't touched it for a couple weeks, it's going to be wiped out because all this lives in temp space. So if something is critical, you got to download it just like I try to download, I guess. Remember, when this thing finishes at the end, you can and you should always go to the output files and select the ones you need and just download them locally because otherwise they're going to be wiped out. All right, so tomorrow we're going to see the status of some of these calculations. They're going to be done in an hour or so, but we're not going to wait for them.